Hi, welcome to Unit 8, Day 1. This is Part 4. So in Part 4, we're going to learn about pH and pOH of acids and bases. So I believe you have seen this before, pH, when we learned about the properties of different substances. And we had to learn what acids are because acids had certain properties. They're covalent molecules, but they had certain properties that didn't fit with most covalent molecules. So you've probably seen this pH scale before, and you may have seen something like this if you're using pool equipment, for example, like measuring the pH of pool or of the soil. So what is the pH? pH is a scale. It's typically written from 1 to 14, but it can go lower and higher than that. And it's used to measure how acidic or basic something is. The lower the pH, the more H plus in solution. And you know, if the more H plus you have, the more acidic it is. On the flip side, the higher the pH, the less H plus, and therefore that usually means the more OH minus in solution, so the more basic something is. So heading down on the pH scale, you're going to get more acidic, and then heading up on the pH scale, you're going to get more basic. So in terms of where the cutoff markers are, if your pH is less than 7, you're acidic. If your pH is at 7, you're neutral. And if your pH is greater than 7, you're basic. So how do we measure pH? We can measure pH using a pH meter, or you can even use pH paper. So for a pH meter, you just stick the probe into the solution, and then there'll be a digital reading that tells you what the pH is. And again, you can refer to the scale to figure out if you're acidic or basic. In the case of pH paper, which you've probably seen before, these are these little strips. They are soaked in an indicator, and the indicator changes color depending on how acidic or basic something is. And so if you take the strip and you dip it into something that's acidic or basic, it will change color, and then you can use the color code here to figure out what the pH is based on the color that the strip turns. All right, so I want you to use the images to identify if the solution is acidic or basic based on what you see here. So go ahead and pause the video now. You're going to do that for both A and B. So is it acidic or basic? Pause the video now. When you press play again, the answer will be revealed. All right, so A is a base because it turns the pH paper like a purplish blue color, and you can see here that falls in the category of a base, the pH greater than 7. So it can be something like 10 or 11. That's what that color looks like. And so it's basic. And here, if you look at the pH probe, it reads 2.86. So if a pH is less than 7, 2.86 is less than 7, it's going to be acidic. All right, so we looked at how we can determine it experimentally, but we can actually also calculate the pH. And you can calculate the pH by using this equation. pH is equal to the negative log of the concentration of H+. So what do we mean by concentration of H+? Concentration is measured in something called molarity, which you're going to learn about later. And that's the moles of the solute, so the thing that's being dissolved, divided by the liters, or the volume, of the solution. All right. So if you know the concentration of H+ in solution, you can go ahead and plug it into this equation, negative log, and you can get your pH that way. So let's look at an example. We're going to calculate the pH of something. So we want to calculate pH of a solution whose concentration of H+ is 0.0861 molar. So I'm also going to show you how you would plug that into a TI-30 calculator. So we know the equation is pH is equal to negative log concentration of H+. So all I'm going to do is just plug the 0.0861 molar in for my concentration of H+. And so it looks something like this. pH equals negative log 0.0800. Sorry, that should be just 10861. All right, so I just made that correction there. Okay, so we have our equation. Now, how do we put that in the calculator? First thing we're going to do is we're going to press the negative sign button, not the minus, so it's the little negative sign. So we go ahead and hit that. And we get a minus sign on our calculator. And then the next thing we're going to do is we're going to press the log button, which is up here over underneath the second. So just hit that log button, and then we get minus log, okay? The next thing that we're going to do is then we're going to type in the value of our concentration, so 0.0861. So just using the keypad there to type in 0.0861. And notice that the log has an open parentheses, so I always like to close the parentheses. Technically, in this example, you don't need to, but it's a good habit because sometimes you definitely need to if you're using this in a longer calculation. So go ahead and close that parentheses. All right, so now the parentheses is closed. The next thing we need to do is just hit enter to get our answer. And we get 1.06499 blah, 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 which I'm just going to round to 1.1. So if you have a solution whose concentration of H plus, the amount of H plus in that solution is 0.0861 molar, then the pH of that solution will be 1.1. Okay, so I have a CFU for you to do now. I want you to calculate the pH for the 3 solutions below in the table, solutions A, B, and C. And I want you to then, after you calculate the pH, I want you to label it as acidic, basic, or neutral. Now, one thing to note here is that for the concentration of H+, I wrote it in scientific notation, so like 1 times 10 to the negative 7. And I also wrote it in decimal form. If you're not sure how to put it in scientific notation in your calculator, then go ahead and put it in decimal form. The number of zeros would correspond, including the 0 before the decimal, would correspond to the power. Or you can just type it in as you see here. All right, so get to it, solve the CFU. When you press play again, the answer will be revealed. All right, so for solution A, the pH is 7, and that will be neutral. Solution B, the pH is 9, so 9 is over here, that's on the basic side. And then for solution C, the pH is 5, which is on the acidic side. So one thing you may notice, though, is that logs, remember logs are, the answer to a log is a power, so it's asking you what the power is. Now, since all of these concentrations of H plus are 1 times 10 to the negative something, then you're going to take the negative value of that power. So notice how the pH for 1 times 10 to the negative 7 is just 7. And that's actually a neat trick for estimating it, because if this was something like 2 times 10 to the negative 7, the pH would be around 7. Okay, just so you have some sort of sense about that. Anyway, last thing I want to talk about is pH versus POH. So remember we just looked at the pH scale. There's also something known as the POH. Whereas in the pH scale, it measures acidity by measuring the concentration of H plus in solution. The POH measures basicity by measuring the concentration of OH minus in solution. And just like with the pH, the lower you go, the more acidic it is. Well, the lower the POH, the more basic it is. Now, you can measure the POH just like you measured the pH by doing negative log concentration of OH minus, right? So you can just do the same sort of thing, but since it's POH, we would use OH minus, not H plus. Or you can calculate it by using this equation. pH is equal to 14 minus POH. And that's because if you look at the scale here, so we have the POH scale on top and the pH scale on the bottom. If you take the number for POH and the number for pH right underneath it, they correspond to each other. 1 plus 13 will give you 14. 2 plus 12 will give you 14. 3 plus 11 gives you 14. And that's because when you add the POH and pH together, they give you 14. So that's where this sort of equation comes from. Oops. Oh, my goodness. Okay. So anyway, so that's how we can use the POH scale. All right, next CFU. If the pH of a solution is 11.2, what is the POH? And you can use that formula here. Pause the video. When you press play again, the answer will be revealed. All right, so all we do is 14 minus our pH of 11.2 gives us a POH of 2.8. And I'm showing you roughly where that is here. So POH of 2.8, this is 2, that's 3, so 2.8 is around here. And that does correspond to 11.2 on the pH scale below it. Okay, so that is it for that part. We're now going to move on to our final section, which is part 5, where we look at strong versus weak acids and bases. All right, so there are a couple of videos here where I want you to figure out which acid is strong and which one is weak. So the first video shows aluminum foil with hydrochloric acid. Oops. So he has a piece of aluminum foil and he added about 10 milliliters of hydrochloric acid. And very quickly, the hydrochloric acid ate through the plastic coating aluminum foil and started reacting with the aluminum foil. All right, let's take a look at a second video. And this is the reaction of aluminum foil with some vinegar. Just gonna speed this up a bit. So I added about 10 milliliters of vinegar to the aluminum foil. So as you can see here, there is no reaction. It's been a little bit of a while. Nothing has happened. And so we can clearly see here that there's no reaction happening. And even when I added a lot more vinegar, nothing happened. And in fact, it's been waiting for over an hour and nothing's happening. All right, so question then. What do you think is, which acid is strong? Is it the HCl or the vinegar? Well, of course, many of you are going to say it's the HCl because the HCl really tore through that metal, whereas the vinegar really didn't do much. And eventually it would do something, but it would take a lot longer to do that. So let's talk about strong versus weak acids. What do we mean by that? One way that you can sort of think about strong versus weak acids is on this pH scale. Remember, the lower you are on the pH scale, the stronger the acid is. So what makes something strong versus a weak acid, or even a strong versus a weak base? The stronger the acid, the more H plus is released into the solutions, therefore the lower the pH. And there are two things that determine that strength. One is the concentration. So the more concentrated the acid, the stronger the acid. The other thing is the nature of the acid. Some acids are classified as strong acids just based on their ionization. If it goes to completion, like it all breaks down into H plus and the anion, or if some of it breaks down in incomplete ionization. So let's take a look at that. If we have a strong acid like HCl, if you put that in water, all of it's going to break apart, virtually all of it, into H plus and Cl minus. Whereas if you have a weak acid like HF and you put that into water, some of it is going to break apart, like maybe 1 out of 3, but you'll still have some together as HF. And since you don't have a free H plus floating around in solution, this has fewer H pluses than the stronger HCl. Now there are a list of acids that are considered strong. So you might want to pause the video now to take a look at this list. If an acid is not on this list, it's a weak acid. So let's try this CFU. Which of the following is a weak acid? Select all that apply. Pause the video now. When you press play again, the answer will be revealed. The answer is B and C because those are the two acids that are not on this list. The other acids, H2SO4, sulfuric acid, and HNO3, nitric acid, are on the list. Now, just like what makes an acid strong, or what makes a base strong, it's the same sort of thing. But in this case, it has to do with the more OH. So the stronger bases release more OH into the solution. And we know that that would have a higher pH, thus a lower pOH. Again, the same two things determine the strength of a base, is concentration, but also the nature, that should say, of a base. So some are strong because of their complete ionization, and then others are weak because they have incomplete ionization. So here's a list of weak bases, strong bases. And if it's not on this list, it's a weak base. And one thing to note is that the strong bases, most of them are in group 1, so from lithium to cesium. And then you have this bottom part of group 2, calcium to barium. All right, which of the following is a weak base? Pause the video now. When you press play again, the answer will be revealed. The answer is A and C. Those are not listed on the list of strong bases, so they must be weak. All right, and I just want to give you a quick note that you can use a periodic table to help you in terms of bases. Again, it's group 1 and 2. And then for strong acids, group 17 from chlorine to iodine are strong. All right, this is our last CFU. Pause the video now. When you press play again, the answer will be revealed. Okay, so here's our answer. So you can go ahead and check that out. And finally, remember there are some properties of acids and